for IIT JAM or GateNet, our courses are being started and we are studying in a full flow. So do join those courses because I have kept fees very affordable, and also I provide everything which is required so that a student can actually qualify the exam with a good rank. Okay, so do look at it. The details I have shared in the group. So now today's lecture, let's start that. So welcome everyone. So this is operational amplifier. It is a very important lecture of the very important topic of electronics. Okay, and this we need 2 days to cover. One, today we will cover the basics of OPAMP. What is that? Because I know in most of the BSc colleges this has been not taught very well. So first we will cover the basics of OPAMP today, and tomorrow we will solve the tricky problems of OPAMP. Okay, but actually how the questions can be tricked in the OPAMP. So OPAMP, the full form of OPAMP is operational amplifier. Okay, operation means something called mathematical operation, and amplifier means the uh, device which actually amplifies the signal. Amplifies the signal means if you put 2 volt, it will make it 4 volt or maybe 10 volt or even more than that. And operation you means multiplication, subtraction. So in our computer, we know that our computer do many mathematical operations like addition, subtraction, integration, differentiation. Every time, whenever we open our computer is doing this. And our computer uses these op-amps to do all these operations. And we will today see how these op-amps are actually used to do all these things. And it is actually a very interesting topic that you are understanding that how your computer is doing subtraction, addition, multiplication, integration. And so I hope you will enjoy this topic. So first thing is let's see how our op-amp in books look like. This is not how our actual op-amp looks, but it is a symbol of operational amplifier. So let's talk about each and everything here. So V1 and V2 are first of all the two inputs, the two voltage inputs. Okay, here these two 10 volts are the voltage supplies, which are the constant voltage supplies which are required to operate this op-amp. You know, in electronics there are two kind of elements. One is called dynamic and one is called resistive or static. For example, if you talk about a resistor, you do not need any voltage for this resistor to work. Okay, whenever you will apply battery, this resistor will work as a, and this resistor will apply resistance to the current. Okay, you do not need any kind of additional voltage for this resistor to work. Okay, these kind of elements are called static. Similarly, capacitor, inductor, these are static elements. Dynamic elements are like BJT, bipolar junction transistor. You know that we need forward biasing and reverse biasing for this transistor to work. Similarly, op-amp are also dynamic. We need some external voltage for this element, for this op-amp to work. And these 10 volt and minus 10 volt, or there sometimes it is 20, sometimes or it can be any voltage depending upon what kind of operation op-amp you are using. So for a very general basic understanding, I have kept it to a 10 volt. So this is operation voltage. So you need this voltage for the operation of op-amp. We do not concern it. It is none of our concern to see at it. Okay. In very few questions we care about this. Okay. Now this is our output voltage and this is our open loop. Our operational amplifier is working in open loop. What I meant by open loop is I am not connecting my output to input. It is completely open. Inputs are coming, it is passing through op-amp and we are getting output. No feedback. Feedback means giving some part of output voltage to input is called feedback. No feedback is given here. So whenever such situations are there, we call it our circuit is open loop. The two important things to see here is this negative and positive side. This negative side is called inverting terminal. So please note it down, inverting terminal, and this positive side is called non-inverting terminal. And the voltage connected to minus negative side is called inverting voltage, and the voltage connected to positive side is called non-inverting voltage. Now let's understand what is this inverting and non-inverting means. So let's assume that your op-amp actually has a amplification of A, open loop amplification A. What is A? A is V output divided by V input. So let's say if your input is 2 volt and your amplification is 10 times, A is 10, then your output voltage will be 20. So you just multiply this by this number. So this is actually a meaning of open loop amplification. So now in case of op-amp, how this thing works. So let's say for first case, I am making V2 equals to 0. It means I am grounding this, and only voltage is inverting voltage V1. So let's say V1 is 5 volt and my A is 10 fixed. A is 10. I am keeping A equals to 10 fixed, and this A depends upon your entire op-amp construction, how your op-amp is made. That will decide the A. So in questions you will be given what it is a value of A, and this is always remember open loop amplification. Okay. Now let's say your V1 is 5 volt and your V2 is 0 volt. So your output voltage will be 50 volt 5 multiplied by 10, but minus. Why? Because the input was attached to the inverting terminal. If the input is attached to the inverting terminal, then your output voltage is negative even when your input voltages are positive. Both of these were positive. One is plus 5 and one is 0. But since it was connected to the inverting terminal, inverting means reverse it, then your output will be minus 50 volt. And because amplification is 10, so 50 should be the magnitude and minus sign is coming because of this inverting. Now coming to the second case, I am putting this 0 and this is as plus 5. So now your output will be plus 50. Okay. Now the case comes, let's say I put it as 3 volts and this as 2 volts. Now, only because of inverting terminal, my voltage should be minus 30 volt. And only because of my positive terminal, my voltage should be 20 volt. So my net voltage is minus 10. Or for simplicity, subtract these two. So it is 1 and see which one is bigger. So inverting is bigger. So minus 1. So minus 1 multiplied by 10 gives me minus 10 volt. So please switch off your mic if you do not have any question to ask. Okay. Keep your mic switched off. Okay. Thank you. Okay, so this is how the things work. So now I have a very simple question for you. Let's see how many of you have understood it. So I have 4 volts here and 4 volts here. So what will be the net output voltage?
0.
How many of you say 0?
0.
0. 0. Okay. Sometimes this op-amp is also called differential amplifier. Why? Because the internal working is depending upon differential op-amps, operational amplifiers. Why differential? Differential means because it do not amplify V1 and V2 both. It amplify the difference between them. And what is the difference here? 0. So that is why output is also 0. In previous case, you see here I put 3 and 2 and answer come 1. So it only amplified this 1 volt and gave me 10 volt. So that is why the operational amplifiers always amplify the difference between the input voltage. So this is the first thing. So in op-amp, you first need to understand the symbol. This is a triangle symbol. Minus plus sign means inverting and non-inverting. V1, V2 are input voltages. 10 volt and minus 10 volt are your voltages required to operate op-amp. And V output is the output voltage which you will get. And this entire op-amp has some amplification, open loop amplification, which is A. So any question till here? I'm giving you 5 seconds. If you have any question, ask. Okay, so if you don't have any questions, so let's move forward. So there are two kind of op-amps. One is ideal op-amp. We always have in physics ideal things, and one is practical. In questions, in most of the questions, at least in the syllabus of physics, we only have ideal op-amps. We do not care about practical op-amps a lot. That is the issue of electrical engineering. So in ideal op-amps, there is one thing which you should note. That is that the input resistance of this op-amp is infinite. What do you mean by that? So for a second, I am just removing these symbols to explain you. So let's imagine inside this op-amp, definitely there will be some circuit, and this circuit will be something like this. There will be some input resistance, there will be some output resistance, and there will be some circuit in between. So whatever the circuit you have inside this op-amp, that circuit has infinite internal resistance, and it has a very important consequence that we will just see that this input infinite resistance is very important, and we will just see how. The output resistance is zero. So always remember that in many papers, even the direct question can come. Okay, in MSQ, I have seen sometimes question asks, op-amp has infinite internal resistance. It has infinite output resistance. So there are four options, and more than two or three are correct. So please remember this. And the gain which I was talking about, it is 10. It is not actually 10 in ideal. It is infinity. It is infinity. So now I have a very wonderful question for you. Okay, and I will answer it also. So let's say your voltage is here 2 and here it is 1, or let's say 3, and it is an ideal op-amp, so amplification is infinite. So what is your V output? Give me an answer, very quick answer. What is the first answer that comes to your mind? Huh? Infinity?
Not defined.
Not, it is not defined actually. It is means answer is not defined. It is, so technically your answer should be infinite. Technically. But now just imagine, can we get infinite voltage from any circuit? So then our entire energy crisis will be over. Okay. Our voltage answer is 10 volt. Why it is 10 volt? Because we are only giving 10 volt to our op-amp. Okay. Our output definitely depends upon internal voltages, input voltages, but the maximum limit cannot cross 10, because this is a maximum energy we are giving to our element. So if you are giving total maximum total 10, then our output cannot exceed 10. Okay, if our input battery has 5 volt have 5 volt EMF, then maybe you can design a circuit in such a way that we control V output, but it can never exceed 5 volts. So now I have based on that, I have a second question. So let's say now it is 3 and it is 2. What will be the V output?
What is A? -10.
Minus 10, definitely. Okay, so minus 10. So if your A is infinite, then your answers come as saturation voltages, and these are the saturation voltages. Okay. Okay. So that is why, do you think we should use our op-amp in open loop circuit? Because in open loop amplification is infinite. So we can never control V output. Every time our answer will come out to be either plus 10 or minus 10. So there is no use of using our op-amp in open loop circuit. Even if in practical circuits, our amplification is 400, 500. In that case also, every time we exceed 10 volt. So what should we do? So we use negative feedback. So the negative feedback means taking some of the output voltage and attaching it to the input voltage. So now there are two questions in front of you. First question is, should we use negative feedback or positive feedback? And why we are using negative feedback? So the answer to first question is yes, we should use negative feedback. And why means why? Because we want to reduce our amplification. It is infinity and we want to reduce it. So whenever you need to reduce it, what do? You do negative feedback. Negative feedback means putting the output voltage in input voltage opposite to the input voltage. Means agar if your input voltage is 5 and it is 2, okay, then you are putting it in opposite. So their subtraction is 3. So you are putting -2 coming up here. So your difference of this voltage will become 1. So you are in kind of putting negative feedback. We will see it more right just in a bit. Okay, how this actually works. So negative feedback. So how we give the negative feedback? Just attach your V output to the non-inverting terminal. No, oh sorry, inverting terminal via some resistance which is R2, via some resistance. If you do this, your OPAMP is said to be in negative feedback. Now comes the very important concept of OPAMP, and I want you to give a very focus here that what is the concept of virtual ground. So for that instance, I am just need to remove this symbol so you understand it. Now I said yeah, internal resistance is infinite. It is still infinite because it is an ideal OPAMP. Okay. If the resistance is infinite resistance, and this is voltage, let's say some voltage. If this point is called A point, then this is called VA and this is called V2. So if the resistance is infinite, what will be the current flow in this wire in this direction?
0, sir.
0, because in resistance is infinite, so no current can flow. If no current is flowing, can I say VA is equals to V2? Can I say? So I am repeating it. I am just explaining it. Let's say this OPAMP has an internal resistance like this, which I already mentioned that it is infinite. For ideal OPAMP, it is infinite. So I am just redrawing this circuit here. So let's say this point is called A and voltage at this point is VA and voltage at this point is V2 and there is infinite resistance in this path. So what will be the current flow here? It will be 0 because whenever there is infinite resistance, no current can flow. If no current can flow from one point to another, it means the potential of one point is equals to potential to the second point. Am I right or wrong?
Right.
Yes, Bhaiya, right.
So this
Right.
is called the concept of virtual ground. Whatever is the potential of this point, that is the potential at that point, and that is called V2. So always make, whenever you have a question of OPAMP, always use one concept, that is virtual ground concept. Voltage of this point and voltage of this point are equal. So what now in this case, we have now 2-3 questions in front of us. Now what is the new amplification? That is what is V output divided by V input. Okay. Now what is the output which I will get? Before I was getting saturation voltage plus volt, and now what I so for that we need to do some calculations and we will use virtual ground concept here. So for this circuit, any circuit can be given to you in the question. So now let me come back to this symbol minus plus. Okay. So this is voltage V1. So let's say current I is coming from this line. Now no current can go this side. Okay, no current can go this side. Okay, because we just saw that no current. So this entire current will flow up. So this is II. Okay, or let's say IF. Okay, II and IF are equal, but I am just giving it a separate symbols. That's it. And this current will reach here. And the second thing which we mentioned here is VA is equals to V2. These two things, if we have these two things, then we have our calculations all done. So let's do it. So let's use this fact that II is equals to IF. So what is II? Carefully see this. Have I written it right? VI minus VA divided by R1 will be II. So there is
Yes.
one point here. Let's say this is VA, this is VB, and there is resistance R in between. So what will be the current through this loop? That will be VA minus VB divided by R. Okay, since the current is flowing in this direction, it means this is at higher potential, this is at lower potential. So I have to subtract V1 minus VA, V1 minus VA divided by R1. Very simple concept. Now what is this IF? So similarly, VA minus V out, VA minus V out divided by R2 divided by R2. So now the second thing I need to use is VA is equals to V2. So VA equals to V2. Now I just need to find V output. I need to find V output. So what is VI here? Sorry, it is not VI, it is V1. Sorry, V1. Okay. So now I just need to find V output. So let's do the calculation. Very simple calculation. R by R1. Here also I need to write V2. So V2 minus V out. So what is the value of V out? So V2 minus R by R1, V1 minus V2. So do these calculations, complete these calculations. 1 plus R by R1, V2 minus R by R1, V1. Okay, this is the calculation. Now I just want you to show you that it is not actually infinite. I am just doing one very simple thing. Very simple thing. So let's assume that V2 is 0. Let's assume this is 0. Okay, what is my new output voltage? 1 plus R by R1 into V. Sorry, V2 is 0. So minus R by R1, V1. Now I want you to answer this. If this was 0 and this was something, let's say 1 volt or something, if I do not had the negative feedback, what was my output result? Minus 10 because I am applying it to negative side. But now what is my output? This is my output. And it is not at all infinite, not at all saturation voltage. It is something else. I can decide what it should be based on what is the value of resistance. These resistance I am applying. So I can apply any amount of resistance and decide what can be my output. So now my amplification is being reduced. So whenever someone asks you to find the amplification, just do V output by V input. V input is V1. So my amplification is R by R1. So everyone understood till here?
Yes, Bhaiya. Yes, Bhaiya.
Okay. Any girl should answer. Boys, 2, 3 I know who are understanding. Everyone else, do you understand till here?
Yes, sir.
Okay. So
Yes,
this how these calculations have been done. Now let's understand it more. When we apply it to some applications of the OPAMP. Once you do this, your entire concept of OPAMP will be clear. One very important application of OPAMP is voltage follower. Voltage follower means whatever is your input voltage, that will be your output voltage. Sometimes in electronic circuits, we need voltage follower. Okay, because we want our input voltage to go as it is to output voltage. So we cannot use actually wires. One very simple question comes, if this from this point to this point, if at this point we have voltage 1 V1 and this point also we need this same voltage, then just connect these 2 points by wires. But wires cannot be used. Can anyone answer why wires are not used? Do you understand the question? If your input and output needs to be same, just connect them with wire, na? Why we are using this voltage follower?
Wire has have some resistance.
Yes, wire has, you cannot make a wire with zero resistance. So wire will have some resistance. So some potential drop will be there and this V will not, this V will be less than V1. That is why we do not use wires. We use voltage followers. So how this voltage follower work? So you just apply your voltage to the inverting, non-inverting terminal, that is positive terminal, whatever is the voltage you require at the output, and connect the V output to the inverting minus terminal without any resistance in between. Without any resistance in between. So now I just need a very simple answer. If this point has a voltage V output, then what will this point will have voltage?
V output.
V output, because both points are just connected. So now if this is V output and this is V1, will this be equal? Using the concept of virtual ground?
Yes.
So that is why we get V output is equals to V and 1. So this is voltage follower. So whatever is the input voltage, that is our output voltage. Perfect. Second thing comes adders. Adders means you have 2-3 voltages and you want to add them. How will you add them? So that for that circuit, you can just remind this circuit later on, just you can understand it right now. What you do is you apply a voltage, then in front of a resistance, second voltage, then again a resistance, third voltage, then again a resistance, connect them all together and give it to the non-inverting. Oh, sorry, I'm again and again making this mistake. Give it to the inverting terminal minus and ground your positive or non-inverting terminal and give your feedback by applying a resistance. This is a very simple circuit. Once you do 3-4 problems, this circuit will you will actually very much remind that how this circuit works or how to draw this circuit. So now let's understand how this circuit is actually working. If this voltage is 0, since it is grounded, what is this voltage?
Zero.
0. 0. This is called the concept of virtual ground. Do you understand the word virtual ground now? This point is actually not grounded, but still the voltage here is 0. So it is acting like a virtual ground. Okay, that is why the name virtual ground came. But sometimes people, because initially the teacher says it is 0 0, so every time students put 0 voltage here. No, it should not be 0 always. It should always be equals to whatever the voltage is here. If here 0 voltage is not there, here also 0 voltage won't be there, then the word virtual ground is actually a wrong word, but here it is the right word, virtual ground. So now the current I1 is coming in this loop, I2 is coming in this wire, and I3 is coming in this wire, and they all are adding up here as, let's say, I, and the same all I current is going up. And just for the different word, I am saying this word is IF. So I is equals to IF without any problem. I is equals to I1 plus I2 plus I3. Very simple. No problem till here. What is I1? I1 is V1. Since if it is 0, this point is also 0. Simple. So I1 is V1 minus 0 divided by R1. V1 minus 0 divided by R1. Similarly, what is I2? V2 minus 0 divided by R2. What is I3? V3 minus 0 divided by R3. And what is IF? 0 minus V output divided by R. So what is V output? R V1 plus V2 plus V3 R1, R2, R3 and minus sign. So for a very simplicity case, because we want to add them, assume that R1 or not assume, just you have your resistance in your hand, you can put any resistance. So R1 equals to R2 equals to R3 equals to R. So what will be V output? Minus of V1 plus V2 plus V3. So what do you got? You got the addition of all three input voltages. Only thing is you will get a negative sign. You can avoid this. Okay, you can actually avoid this. So as an output, you got the sum of all three. Everybody understood how the voltage addition, so what is this adder works?
Yes, Bhaiya.
Okay, I need at least 5 years before I move on. Do you understood?
Yes,
Yes.
sir.
Yes, Bhaiya.
Yes, sir.
Yes.
Okay, absolutely great. Then comes differentiator. Let's say now I say that I have some input signal and differentiate it. So let's just see the diagrams of this means how this input circuit signal will be and what will be the output signal then. So let's see that first. We are trying to differentiate it. So first question I have for you, if I give this square input and I differentiate it, what will be my output? This is my V input. You know, na square pulse signals. Sometimes you give in electronics, you have square impulse functions. And I give this. So what will be your answer? If I differentiate it, what will I get? So what is a voltage here? Constant?
Yes.
Constant voltage? If I differentiate constant number, what do I get?
Zero,
Zero.
sir. Zero.
Zero. You get zero. So your signal is like this. You get peaks. Why peaks? Because see very carefully. At this your signal is increasing, at this your signal is decreasing. At both points answer should be zero. But it do not go zero very immediate. Okay, because your signal is little bit changing here, na? So that is why you get a peak here. As soon as you apply this here constant, it goes to zero. Again, it is negative again. So it's some kind of peaks you get. Very sharp peaks, very no almost no width at all. Very sharp peaks at these lines you get, and in between you get zero. These peaks you get because the voltage is in changing. Here voltage goes from zero to positive, from positive to zero. That is why you are getting the peaks. Now second thing, let's say I have triangle signal. What will be the output?
Some number.
Yes. So what is an equation of this line? V equals to T. Voltage is a function of time. Okay, at time t equals to 0, voltage is this, at some time it is this. So what is this line means? V equals to t, this is an equation of line. So if you differentiate t, dv by dt you get constant. So you get square pulse. Before we had square pulse and we differentiated and got peaks. Now we have triangle. So it, if you differentiate it, you will get square constants, which is actually squares. Square pulse wave. So everyone understood?
Yes, Bhaiya.
So if you have triangle wave and you want to make a square wave, how you make it? You just put it in the differentiator. And how this differentiator works, now let's come to that. So differentiator use one more element which is called capacitor, a new element. In this, simply put your input voltage to the inverting terminal via capacitor, and feedback is similarly given via resistor. And your positive side is still grounded just like the previous case. So if voltage is here 0, here 0, absolutely fine. The current here I and this IF are equal because current comes like this and goes up. It cannot enter this side. So I is equals to IF. Now we have to use a capacitor knowledge to find this I. So first you need to tell me what is actually I. It is dq by dt. And what is q?
CV.
CV. And what is this V? V is a voltage applied across this capacitor, and that is V1 minus 0. V1 minus 0. So you get C dV1 by dt. So I is C dV1 by dt. I can again repeat it. This current I is equals to dq by dt. We know that, and in capacitors we know Q is equals to CV. C is the capacitance of the capacitor, and V is a voltage applied across this capacitors. And what is a voltage applied across this capacitor? That is V1 minus 0. V is V1 minus 0, and C I have put outside the differentiator because it is constant. So I just got C dV1 by dt. Now let's do this. What is IF? It is 0 minus V output by R. Everyone understood that? So V output is minus RC dV1 by dt. So what do you got? The differentiation of input signal, and this is just a constant, multiply by constant, doesn't matter. So you are getting differentiation of your input signal. So everyone understood this, how differentiator works?
Yes,
I
Bhaiya.
need, yeah,
Yes.
I need more. Yes,
Yes,
good.
Bhaiya.
Perfect. So differentiator works. The last thing we are left with is integrator. If we want to integrate the circuit, so very simple. So in this circuit, capacitor was here and resistors was here. Now just reverse them. So put resistor here, capacitor here. So now again, if voltage is here 0, here 0. Again, virtual ground concept I am applying again and again. This is I current and this is IF current. These both are equal. Okay. So what is actually IF now? IF is dq by dt, d by dt of CV. V is a voltage applied across the capacitors. And what is that voltage? That is 0 minus V output. There should be one minus. Yeah, so I have put minus it. Good. So it is minus C dV output by dt. So what is IF? It is C dV output by dt. What is I? I is V1 minus 0 by R. So V1 by RC is minus is equals to dV output by dt. So now integrate both sides. So I got y minus 1 by RC V1 of integration. So what do I get? I get the integration of input. So everyone understood how this integrator work?
ये फिर वापस से बता.
Okay, this I can tell again. So input current is coming like this, and all that current goes to this feedback because no current can go here. So I is equals to IF. What is IF? IF is again dq by dt. And what is Q? It is CV. C is the capacitance of this capacitor, and V is the voltage across this capacitor. What is the voltage across this capacitor? It is 0 minus V output, 0 minus V output. So I just simply got minus C dV output by dt. So at the place of IF, I have placed this. What is this I? I is simply V1 minus 0 divided by R. V1 is 1 minus 0 divided by R. So I just simply got this minus V1. I put this C here. So minus V1 by RC equals to dV output by dt. So now here do integration. So what is V output? 1 by RC is constant. So it is just the simply integration of V1 dt. So output at output I am getting the integration of input. Okay, everyone understood?
Yes, Bhaiya.
Yes, sir.
Perfect. So this is all about today's session. So tomorrow what we will do is we will actually solve the problems of OPAMP. This was the basics of OPAMP. Most of the times in JAM, the basic question come from integrator, but also now the question can come is any random OPAMP circuit and they ask you to find currents, or sometimes they ask you to find output voltages or so on. So that we will solve tomorrow. So by that time, so see you all. So let me stop the recording and